Hello guys, this is Miss Samra. So this is my first lesson online and we're going to be learning about 7-4. So this 7-4 is about properties of logarithm. So let's just start off with the essential question. So it's totally up to you if you want to take notes or not. That's completely, I'm not forcing you. It's completely up to you. So here's the essential question. So we're going to be learning about log properties. So how to apply properties of logarithm or log functions. Alright, so why do we need these properties? Actually, we're going to be learning about expanding and condensing of log function. So when I say expanding, it means we'll start off with one expression with log. So you will see one expression and you have to make it into multiple pieces. So you need to break it apart into multiple pieces. So that's called the expanding process. When it comes to condensing, so basically pretty obvious. So it means it's just going to be other way around. So you'll start off with multiple pieces of big function and we just have to make it into single log. So we need to condense it into one expression. So I repeat, expanding, you start off with one, you make it into multiple pieces. Condensing, you start off with multiple pieces, we make it into single expression. So for expanding and condensing, we have three different properties. First property is called product property. Product property. Okay, it means if you have log of some base A, and things are getting multiplied like this. So now we are expanding. I see two pieces of this expression means once I expand, so every single piece would have log with same base A, but you just have to break these apart. So I need to put into two different terms. So I would put x with the first one, y with the second one, since it's getting multiplied, so I just need plus in the middle. So that's how we expand. Let's say I have the second one, which is called quotient property. So how to apply that? Pretty simple. If you see log with some base A and expressions are dividing like this. So again, just like the first one, you would have log with same base A. Since I have two terms and both dividing, so pretty much I just have to break it apart like this and put a negative in the middle. Why? Because it's dividing. And the last one, this is called power property. Okay, so according to this property, so if you have log of some base A for x and that x has any exponent on the top. So what do? You just have to move this exponent to the front. So this becomes n times log of x to the base of a. So that's how we do it. So today's lesson is totally based on expansion of log expression, and tomorrow's video is going to be on condensing. So let's look at first example on expanding. So here's expanding. So first example, let's say I have log. I have 4 times x times y to the second. All right, so in order to expand, log and the base stays the same. Okay, since I see 3 different pieces, you have to take every single piece. No matter it's a number variable, you have to take every single one. I see 3 pieces, so it means I would have 3 log terms with same base 2. All of getting multiplied, so I would put 4x, y to the second, and pluses in there. And the last thing, I see this last term has square on the top. So based off last property, you just have to move this 2 on the front. So that would be my answer. So pretty much the same thing with this 2 on the front. So that's my answer. Okay, next example. Let's say I have log of some base 3 and I have 5 times radical x over 2 times x. Okay, what I would do is first I'll see how many pieces I see. I see 5, this, 2, and x. Total I see 4 pieces. It means I would have log base 3, 4 different pieces. Almost there. Now this one I would have 5. So since 5 getting multiplied by this, so I would put plus. Oh, radical x. You know radical square root can be written as 1/2. So it means technically this is x to the 1/2. Then this is, oh, now I have 2 and x both dividing. So this is, now you have two different ways you could do this. You can put a negative and put this whole expression in parentheses because both of these dividing. And I would put 2 and plus and x. Or you could actually rewrite this. So I would do 3, 5. Oh, I still have to simplify this. You know, this exponent would be on the front. So this would be 1/2 log of x to the base of 3. And then you can distribute this negative. There you go. So that would be my, oh, my bad. I'm sorry. This would be a negative. So that would be my final answer. So I just have one last example to show you, and that's pretty much all for the day. So let me show you the last one. Let's say I have log of cube root of 5 and x. So first thing, yeah, I see two things getting multiplied. There's a cube root, so let's simplify first because you know cube root can be written as 1/3. So let's rewrite this as 1/3. Could you pause it? Yeah, just pause it.